So today we're going to talk about functional programming and some of the patterns and practices that kind of gravitate around functional programming. So let's start off with what exactly functional programming is. Basically, it's a style of programming, and it's a style that focuses mainly on the computation or mathematical equivalency of a function. And one of the main ideas behind functional programming is that you try to avoid creating and maintaining state in your application. Pure functional programming means you have like almost no state in your application whatsoever. When you're using JavaScript, you're going to have state in your app, but there's things that we can mix in from this functional programming perspective that helps write some very clean and very well organized code. So if we compare styles from JavaScript or an object-oriented programming language, we'll find that we use a lot of fixed expressions. We do things very imperatively or step-by-step to create and maintain state in an application and create our programs that way. Through functional programming, we do things more of an imperative way. I said that backwards. When we're using imperative programming rather than functional programming, we use those series of steps. And then another thing that you can tell if you're writing imperative code or non-functional code is if you have a function that takes 0 parameters or a function that returns nothing. That means you're executing a function that's going to change your state in some way, shape, or form. Because if you're not passing in a variable or receiving one back, or you're not passing in a value or receiving one back, then you're doing something with the state of an application. So those are the things we're going to try to avoid when we use functional programming. And just for the sake of pointing out one more time, these aren't mutually exclusive things. You can mix functional programming. I do C# as well, and there's functional programming aspects that I mix in with my object-oriented patterns. Same thing with JavaScript. You can mix in these functional patterns. So again, we're going to focus on inputs and outputs. We want to write functions that have a single, ideally a single input and a single output. We want to avoid maintaining the state of our application. We don't want a function of food that does God knows what because it's behind the scenes just changing values in our app. And then we want to also focus on separating our data from our behavior in our applications. So we don't want to create functions that store data, manipulate that data within it, and things like that. And this has been a pretty popular topic as of recent. I went to Codepalooza earlier this year, and I think there were 3 or 4 functional programming workshops happening at the exact same time. So why is it picking up in popularity right now? My opinion is that multi-threaded systems are one of the big reasons that this is gaining popularity right now. You're not necessarily writing multi-threaded JavaScript applications, but you're seeing this happen in other programming languages as well, where they do support concurrency. So it becomes a major issue if you're trying to maintain state in an application and multiple threads are trying to access and manipulate that state. So that's one reason that this is becoming popular. Another reason is applications are getting bigger, right? They're just getting wildly bigger, more complex, and we need simpler ways to maintain those big applications. And one thing that I found is you get better craftsmanship through functional programming. You focus more on writing smaller functions that have one responsibility, and therefore they're easier to debug and figure out what's going on and reason about. So again, just to reiterate, maintaining state is hard, especially in really big multi-threaded applications. So some of the techniques that you'll find here apply well to those scenarios. With ES6 or JavaScript 2015, they added some new functionalities to the standard that allow us to do more functional-like programming techniques. One of the big ones is fat arrows or lambda arrows. These let us shorten the expressions of our functions down to a much smaller, easier to manage syntax. So it's an easier way to write our functions. We'll go over those in detail for some of the newer folks too. I know we've got some code global students, so we'll help explain what fat arrows are. But functions as data and delegation, that's been in there from day one, but we're able to use functions as data in JavaScript, so that's something that's very functional. And also has had the ternary operator for a while, which is something that lets us write if-then statements in very short, terse syntax. Higher order functions, you'll see this being used in functional programming, this terminology. Basically what higher order functions boils down to is you have a function that takes another function as a parameter. So anytime you see a callback in JavaScript, that's basically a higher order function. It's a fancy term that people like to throw around in the functional programming community. That's all it means. It can also mean that you return a function from a function as well. Currying, we'll go over what that is in an example. It's a little bit hard to explain without some visuals, but we'll go over that as well. And then in ES6, we got a lot of non-mutating array functions. So we have things like filter, reduce, and map were added officially and supported throughout all the browsers. So we'll go over some details on what those do. And then I'll show some examples of method chaining and pipeline, which are big fundamentals to functional programming as well. And those non-mutating array functions are what help us build those pipelines. So I'm going to start off with some demos. I have this cheat sheet that I created for work, and I'll share the URL for it when the talk is done so you guys can download it, print it out, do whatever you want to do with it. But it's a great resource, and I'm going to go through it because it has some really good examples that'll kickstart us into the demos with solving the poker scoring problem. So let me get started with that. I'll break out of this presentation. There we go. So this is the functional programming cheat sheet that I created. And the first thing I want to step through is the arrow functions. Arrow functions are extremely handy. And if you're not familiar, I'd like to give a quick demo of what those are. Can you see okay in the back? I can try to zoom in a little bit here. Let's do, there we go. Maybe that'll help a little bit. And let me uncomment this guy first. So in JavaScript, we can write a function like this. We can say, I want a function named multiply, and it's going to take two parameters, x and y, and we'll take those two parameters, multiply them together, and return the value. Alternately, I could write that using an arrow function. So in place of that word function, I can simply put the parameters in braces and write the arrow. That means that we're going to have a function that returns x times y. So we're just simplifying the way that this is written. Okay. One thing that's nice about arrow functions is that now that we have the arrow and we've removed the word function from it, we can do a little more implied behaviors with this. So we can actually remove the return statement because return is implied with an arrow function. So we don't need that. So if you compare to the next example, I can take my x and y and just immediately after the arrow say x times y, and that will implicitly return x times y. So we don't need to spell out all of this stuff. It's reducing the ceremony of the code that we're going to write. So if we compare the final example to the first example at the top here, you can see how much shorter that piece of code became. Much shorter, one line piece of code. Those two things in this block here are identical. So it's a lot smaller, takes a lot less space. When we get into bigger functions and a lot more of them, this comes in really handy. So we don't have to look through a large file identify all the pieces of code that's running in it. So we got onto our next example. Function delegation. Other languages call them function delegates. You often hear that term in JavaScript, but essentially we're assigning a function to a variable and we can pass that function around as data. So in this example, I have a function called isZero that is, it takes a parameter, compares it to 0, and gives you true or false back if that value is equal to 0. So on the surface, that sounds pretty simple, but what's really nice is we can pipe it into an array.filter. So we can take this array of numbers, we can call filter on it, and then we can just pass in that function and say, give me the number of items that are equal to 0. So we can say filter is 0, and then it will spit out the 3 items, the 3 zeros in that array. And we can count that and say there's 3 zeros in that array. So function delegation can be handy. It's good for writing clean code. If you have something complex that goes in that filter, you can bring it outside of the parameter and put it in its own function and give it a proper name. These are handy when you're doing things like mapping. You can just say to, say, people, like it's going to take an array of something and return the people in the array, something like that. And we'll have more examples of this in the bigger demo that I'm about to do. Let's see, this one's another good one to pull up in the browser. Let's try to pop this up. So in this example, I've got a program that's going to give me a salutation of good morning or good afternoon based on the time of day. And let me uncomment the original version. This is usually using code that people might normally write, where we set up a temporary placeholder called salutation. Now, we're not assigning anything to it yet because we're going to check whether the hour of the day is greater than 12 o'clock or not. If it's greater than 12 o'clock, or sorry, less than 12 o'clock, we're going to say good morning. This is before noon, we're going to say good morning. Then we're going to set the salutation to the string good morning. Then we have an else statement that says, well, if it's not 12 or before 12 o'clock, then it's the afternoon, so we can say good afternoon. And then finally, we'll return that salutation. So we can actually do this a lot simpler using a ternary operator. So let's take this and collapse that down and look at another way of doing this. Basically, a ternary operator uses a question mark in place of that if-then statement. So we can take in, and again, I'm using my arrow functions here, and I can say I'm going to pass in the hour of the day. This is my parameter, hour. We'll say if hour is less than 12, then the question mark denotes the if-then portion of the statement. So we say if the hour is less than 12, return good morning. Otherwise, return good afternoon. So we don't have to set up a placeholder variable. It all fits nicely on one line, and it's a lot simpler. I'm going to go through another demo later while I use this, and what's nice is it'll help me identify a place where I can refactor even more because there's a lot less code to reset. Again, higher order functions, basically anything in programming that takes a function as a parameter or returns a function as a result is in a higher order function. All of the array operators that you'll see, filter, map, reduce, those are all higher order functions. Inside of all of those functions is generally a for loop or a while loop. Okay, under the covers, that's what's happening. So if I wanted to create a custom map function, say I wanted to map over 2 items at a time, what I want to do is take an array and I want to pass in a function that's going to run on each time that function or that initial function iterates on that array. So that's what I have here. I have a function called map consecutive, and it's going to take an array and a function. And then it's going to iterate over the array. And every time it iterates over the array, it's going to call that function. And it's going to apply that function to the value that's on the index and the value that's on the index plus 1. So we're looking at two elements in an array, and it's going to loop over those. So if we passed it something like this, just letters A through G, and we did map consecutive, and we want to map those to a two-dimensional array, we would get something like this. We have an array that has an array inside of AB, BC, D, CD, and so on. So it's taking that function of taking X and Y and converting those to an array, and it's repeating that over and over again, and it's applying that function as it moves. That's how higher order functions work internally. We'll use some more of those later on as well. I'm going to skip past currying because it's easier to see in the other demos that I have, and I think the explanation's a little easier there. But it's nice to know that it's in the cheat sheet. If you pick it up later, there's some good examples in the cheat sheet of it. Array manipulation functions. Like I said, many of these are fairly new. New is a relative term, so I've said that to people before, and they're like, we've had it for years. It doesn't mean it's always been available in the browser for years, just because it's been in the spec. A lot of these things are just starting to be standard in the browser, so we can use them without having to do translation and stuff like that. So it's nice to know that we're able to use these things now. These are some of the basic building blocks of functional programming in JavaScript here. We're going to take, for this first example, an array and see if every element in that array matches the criteria of a function I pass. So I could give it an array of numbers, and I could say, is every number in the array 0? And get back an answer. So it's a very short and easy way of expressing something over a collection of data. Sum is kind of the opposite. So we can say, are some values in the array equal to something or match some other type of criteria? So we can give it, say, an array of Boolean values and say, are some of these true? And it will return true if there's at least one true in that array. An overload for that is includes. So you could use includes as well. I think sum is more common to see. Find does exactly that. It will find the very first element that matches the function that we pass in and the criteria that we pass in. Filter will give you a smaller subset of an array of data based on the filter that you pass in. This is extremely handy. Use this all the time. And what's nice about all of these functions that I've talked about so far is they return a brand new array or value. They do not manipulate the array or value that you're calling it from. So if we filter an array of some data, that data doesn't get changed. We get a brand new array of the filtered data back. So these all follow the functional programming principle that we're not going to mutate data. Map will create a brand new array depending on what function we pass in. I've got some really good examples of that one. Won't go into too much detail here. Reduce. Reduce is an amazing function that we can use to manipulate arrays of data into a single value. So we can, for example, calculate the average of something using reduce. We can do very complex things with reduce, and I've got a great example for you guys on that one. And then I included sort and reverse in here, and notice that I put a warning on this. So this is where you can get tripped up really easy because you have things like map, reduce, and filter, and you can call those and get back a brand new array, but if you were to sort that same array, it would manipulate the initial array, the one that's being called on. So be very careful with sort and where you call it and how you call Reverse does the same thing. It manipulates the actual array you're calling it on.
How would those just pass back another array like the others?
Sort and reverse have been in language or in spec for a long time. I don't know if it's a change in what people are expecting or if it's some other deeper thing that's happening. JavaScript goes way back, so there's a lot of old plumbing underneath the surface. So it's been in there for a while. I'm not sure why, but it does indeed manipulate the state. What is nice though is you can use this brand new spread operator, which is part of ES6. So you can say ... in your array name, and then you can say .sort, and that will copy the array and then sort it. So you'll get a brand new value back. So that's a nice little trick to get you a sort without the state manipulation. So that's if any reason to download the cheat sheet and have it on your desk is to have these nice little quick references like that. Spread operator will get you out of the jam for the sort and reverse. With all of these array functions that we have in this version of JavaScript, we can actually chain those together. Since they're all producing an array, we can just keep chaining off of it. So we can say, if, for example, I have a cart of items and I have drinks, I have a steak, maybe this is my bill at dinner or something, I can filter those items by drink. So I only get the 2 drinks. Then I can map these and get just the price. So now I've taken off the names. I've just got the 2 prices in an array. And then I can reduce this and get a total value. So I can sum this. It ended up being $14 and change. And then I can also take off reduce it down to 2 decimal places. I can do that all in one method chain. So I can just say ... I don't have to keep saying cart something and setting it to a variable. So you can see the console output here would end up being total cost of $14.13. So that's what this function called drink total would do. We can just pass it an array and get the value out of it. Pipelines are a similar concept. So some languages actually have a pipe operator where you can chain multiple functions together and keep applying functions to the return value of the previous call. So this is nice if we have some really long tasks that just keep repeating on a single piece of data and manipulating it and making changes to it. And we want to just put that all in a big pipeline and let it run and give us one single output. So you can see in this example, we take a cart of items and we just want to tally the orders. And we can pipeline those together. And basically, we do that using a reduce function that's being wrapped here. So we can just keep calling on X and applying functions to that value of X. So the first thing would give us a sum, then we would add sales tax, and then we would convert that to a string that says order total equals, and then the final result would actually be the string order total equals $64.62 based on this array of numbers that we passed. So it's a nice way of breaking down a task into a sequence. And that's all for the cheat sheet. I'm going to go over some demos that kind of expand upon some of these ideas. And the demos are available online as well. So if you want to tinker with those in your free time, they're out there. And I'll give links to that as well at the end. But the cheat sheet is great. Great reference to print out, pin it up on, at your desk or whatever. And there's some nice little tricks in here that'll make your code smaller and easier to read. So I wrote this kind of a demo application and I give workshops and stuff. So this is a tool that I use for my workshops. And what we do is we sit down for a couple hours and we solve the problem of scoring a hand of poker, getting the highest hand rank out of that hand of poker cards. We score all of the possible rankings, and then we kind of do some refactoring to see how we can make our code easier to read and try to make it as functional as possible. So I built this kind of pseudo unit testing system. There's lots of great unit testing frameworks out there, but I wanted something a little more visual, so when I'm in a workshop, I can show the data on top of the results. So that's what we have here is this kind of visual unit testing system. It's really basic. It's just basically a React component that has one of the Progress Kendo UI grids in it. So this is our product. We have this really nice grid that you can feed data and it'll display it in a data grid. So I have multiple collections of data that have all of the hands of poker, and we're going to test the functions that we're writing against those hands of poker. So we're going to do things like score the high card. We're going to get the high card from this hand of cards. And then, basically all of the things in poker. We score pair, two pair, three of a kind, straight, and so on, all the way to a royal flush. When we write a passing test, it will collapse that data down and give us a green passing bar at the bottom. So that's what we're going to do. And this is just a React application using our Kendo UI React grid. It's nice for visualization. We get the cards. We can sort the data if we want to see how those values are sorted numerically, things like that. So it gives you a nice visual representation. I'll go back to my slides here too, so I've got some good visuals in here as well. This is where we're at. We're gonna write some of these tests. I can't do them all tonight because, like I said, it takes about 4 hours to complete this and refactor it all. So we'll go through some of the basics. So we have an object that has card suit, the card's numeric value, the card value, and they're basically 2 through 10, and then Jack, Queen, King, and Ace are 11 and up. So those represent a poker card. And one of the first things we're going to do is just kind of make sure this test framework passes. We're going to go into the scoring JS file. Now, scoring JS has 2 functions in it that we're responsible for writing to pass the tests. The first function is getting the high card, and the second function is going to rank the hand. So no matter what data we pass it, it's going to give us back the highest hand rank. So let's do our hand rank first. We'll start off with just returning back high card, just to get something going here, right? The first function. So let's do get high card. We're basically just going to pass back the string high card. Now notice that high card turned green up here. The data moved away, so we don't have to look at it anymore. And what's nice about this is we can refactor get hand rank, and we can watch on the right-hand side to see if that changes in any way. If we see it light up red again, then we know we've broken something. So the first thing I want to do here is just make this a little more functional by using a fat arrow. So I'm going to take cards, and I'm going to say just return high card. And remember, I don't need the return statement. It's implicit with a arrow. So now I can reduce that to high card. That's the first thing I wanted to do. And you can see that hand rank, or the high card test is still passing, so we haven't broken it. Next thing I want to do is I want to get the high card from this hand of cards. So if I look at my hand of cards, I have 3, a jack, a 4, a king, and a 2 spades. And what I want to do is I want to write a function that goes through the hand and picks out the highest card object. I don't want the highest value. I want the actual entire object itself. So the card face, the suit, the value, the whole 9 yards. I want that exact object out of it. So what we might do to find this, often what people's first instinct is to write something like this. This is the very imperative way of doing it. First thing we might do is get the first card in the array. So we're going to start at cards 0. And at that index, we're going to call that the high card. So we're just taking the very first card and saying that's our high card. Then we're going to iterate over the array. And we're going to say if the next card, the value is greater than the current high card we're holding. If that's true, then we're going to set high card to that next card. And then once we're done iterating, we'll just pass back whatever that card was. That's a very direct approach to it. There's nothing wrong with it. But what I want to show you is we can actually refactor this down and make it a lot simpler to read. So what I want to do here is I have an if statement. I like the ternary operators. They're very straightforward. They can reduce this down a bit. So I'm going to take away this if, and I'm just going to say if the card value, the next card's value is greater than the high card, then we'll take that high card and we'll return it to the variable high card. So we'll say card. Otherwise, we'll just return the high card. So if we don't have a new high card, we'll just keep the one we have. So what's nice about this is it actually opens up another opportunity for me to refactor this more. This whole ceremony that we're doing where we set up a placeholder and then iterate over a collection and then return a single value actually maps back to something in our cheat sheet. So if we look at the reduce function in JavaScript, what reduce does is it takes an array and it iterates over it and it keeps a placeholder or an accumulator. And every time it steps through the array, we can tell it whether to replace that accumulator with another value or not. It's exactly what we're doing right now. So it takes two parameters, the accumulator parameter and the current value. The function that we need to pass in takes those two parameters. So what we can do is come back into our application or our browser open. Come back into our application. Scoot that down a little bit. And we can replace this with a reduce function that has this function inside of it. So instead of setting up a placeholder value and iterating, I'm going to take that away. And I'm going to say cards reduce. And then it's going to take an accumulator value. I'm just going to call it high card. We need to set up a parameter. There we go. Or so I'm going to call it next card. High card. And then the one that we're iterating on is going to be called next card. And then the function that we're going to pass in that we want to, the function that we want to execute each time this iterates is basically what was in our ternary operator. Almost done. We just need to rename a few things in here real quick. So what we want to have here is cards.I actually becomes next card. And then we can do return. And I'm fat fingering something, so I have a cheat sheet here.
You need to print
That's what it is. Thank you. So I'm not closing this function off. Oh, I is not defined, so we need, it's going to be next card. There we go. So now we're passing. So what we've turned this into is cards.reduce. We're going to take high card, next card. We're going to say if the next card value is greater than high card, give me the next card. Otherwise, return the high card. This is the exact same thing that we were writing to begin with. Now we've taken like 10 lines of code and moved it down to 1. Now that we have 1 line of code, we don't need this function call anymore. We can just say cards and implicitly return. We don't need the return statement. We don't need the braces. So we've taken all of that code and moved down to 1 line. So what I'm going to do in this challenge of writing these poker scoring methods is I'm going to write the entire thing with no variables whatsoever. And I'm only going to use functions. And I'm going to keep 0 state in this hand scoring challenge. So that's what we're doing here. We've rewritten this as reduce. Just to kind of go over what this does exactly. So we're going to take this array of cards, and we're going to start at 7. And then we're going to take 7, compare it to 10. 10 is greater, so we're going to keep it. So now we have 10 and 5. 10 is still greater, so we take 10, and then so on until we get to the result where the king was the highest in that set. Another thing that people like to do right away on this challenge is they like to call it sort. They're like, well, I can just sort them, take the one off the end. Okay? That actually does work. One thing about sort, though, is that sort does this on many iterations, where reduce does it on one single pass. So if you watch this animation, this is a visualization of a sort algorithm. It has more data points in it than just 5 cards, but you get the idea of how this would scale. If you had some kind of business system or something where you're passing in a lot of data, and you want to get the maximum object off of that stack, you don't want to sort it if you can just use reduce and pass through it once. Okay? So for the sake of time, I'm going to jump through some of this, and I'll explain some of the really good parts. But basically, we're going to rank all of the poker scoring hands, with royal flush being the highest, all the way down to just returning the high card, which we've already done. And all of these things are going to go into this handbrake method. And then once we start doing this, we'll notice that there's a couple more challenges that kind of present themselves. Let's see, we've already done get high card. Let's see where we go next. All right, let's jump ahead where we've solved a couple of these. And I want to point out what's happening here. So we're going to solve for the flush in the royal flush. So again, instead of writing logic that has placeholders and things like that, I'm going to use those array manipulation functions. And think of what a flush looks like. We go back to our cards. A flush is basically when all of the suit values are the same. So if we have all spades, then that is a flush. So all 5 have the same suit. One way to solve that is that every function. Remember, we can check an entire array for a single value. So what we're going to do is take, we're going to have a function called hasFlush. It's going to return true or false. We're going to take in the array of cards, and then we're going to say every card, is it equal to the suit of the very first card in that array? So if they're all equal to the very first suit in the array, then they're all equal to each other, and then that returns true or false. So now we have a function that we can just call. It has one single parameter and an output. We haven't created any kind of state to maintain. We don't care what sort order these things are in, any of that stuff. Now what's nice is we have a very simple function with a simple name. HasFlush. We know what that does just by reading. We can solve another problem that we have really easy, a royal flush. A royal flush is when we have all of the royal suits and they're in a 10 and they're all the same suit value. So we have 10 through ace and they're all hearts. That's a good example of a royal flush. We already know how to solve for a flush, which is all the same suit. So we can actually reuse that function. So we'll say has flush, and also every card if the numeric value is greater than 9. So bam, now we have has royal flush. Using two functions together like this is called function composition. That's the fancy term they use in functional programming. We're just using two functions together. There's a lot of different ways to do function composition. This is a very simple way of doing it here. So that solves our royal flush for us. Now, when we call get handbrake, we can just call these functions, and we can do this in many ways. We could do if statements. I have an example of that here. We could use something called a return early pattern. We could say if has royal flush, then return royal flush. If it's flush, then return flush, and so on. And then we have a return default is the high card. It's the lowest hand possible, so we can return that. We could also put that in a single statement with the ternary operator. So we can say has a royal flush, then return royal flush, and has flush, return flush, and then the default value of 5. What's nice about either one of those ways of doing it, that you could use select statements and all kinds of other different ways of doing this. What's nice is when I need to add another scoring algorithm here, I can just press enter and continue on another line, say has whatever, question mark, colon, and keep going that way. It's a nice, easy way of extending this function. So that's what I have here. So it's going to say the royal flush is higher than anything else. Check for that first. If you don't find it, check for the flush, then return the high card if you don't find it. So now we've written the application so far where we don't have any state maintained. We don't have any variables. I've just got constants that contain a function. I'm going to jump way ahead to where we've solved. Yes, they don't call it functional programming because it doesn't have a lot of functions. So I'm going to jump ahead to where a lot of these have been solved. I'm also going to cheat a little bit here and use an external library. This is part of the Kendo UI library, the same library that powers the grid that was over here on the right-hand side. We've solved all these, so it's not showing up anymore. But that grid has really great filtering, sorting, all sorts of really great features for a data grid that you can just turn on. The thing that powers all of those really great features is a library in that package called the Kendo Data Query package. And when we bring this into our application, we have a group by function that we can call. And I said cheat because I'm going to use this external package here instead of writing my own grouping function to solve how to do pairs. So what I want to solve for is getting a pair out of an array. And in order to do that, I'm going to use this group by. And what group by does is when I call group by, I pass in cards, and I give it the property in which to group on, which in the Kendo data query, we call that the field. So I say field is the numeric value. I want to group on the numeric value. What it gives back to me is an array of objects that has that value and an array of items. We can also set up aggregates and things like that. We can do counts directly in here. So So this is the object that comes back. We have aggregates, the field, the value, and the array of items in those that belong to that group. So when I call a group and it looks at this piece of data here, notice I have 2 5s. It's going to group on those 2 5s, and it will give me back an array of those 2 items. So then I can just count, okay, there was 2 in there, that has a pair. So as long as I have a group that's 2, that's my pair, and this works for 3 of a kind, 4 of a kind, and so on. So what I want to do is take that function, and I'm going to start with a generic function, because it can actually find any of a kind as long as I know what I'm looking for, how many I'm looking for. So I have that generic function, I call it has of a kind. Now, has of a kind takes in cards and any number of a kind I want to match. I've also got another, I've segmented this into a smaller function called 2 numeric value groups. So that's actually running my group by. So 2 numeric value groups is basically giving a semantic meaning to group by cards on the number value. And it's telling me I'm going to get back number value groups from that function. So once I have my array of group values, I'm going to say, are some of those the length of that number I'm looking for? 2 of a kind, 3 of a kind, 4 of a kind. So that gives me has of a kind. Now I'm going to show you something that's pretty cool called currying. What I have is a function that takes 2 arguments. 2 parameters here. I've got cards and number. And when I call this, I have a function called hasPair. And I'm going to call has of a kind, and I'm going to pass in cards and 2. And then I'm going to call has of a kind and pass in cards and 3. So I'm kind of repeating myself here, where I'm constantly passing in cards. So there's something that I can do called currying, where I can set a parity on how many parameters I want to put in. So I want to actually just pass in 1 parameter to this thing. I want to pass in just the number of cards, or sorry, the number that I'm looking for of a kind, and not worry about cards, because I'm just passing that in over and over and over again. So what I want to do is I'm going to take the parameters from the has of a kind, and I'm going to move them around. And instead, I'm going to write the function like this. I'm going to say has of a kind takes a number and returns a function that takes cards that gives me the count of, or the true or false of has of a kind. So I'm returning another function that takes that card value, or card parameter. I'm sorry?
That's neat.
Oh, it's pretty, yeah. So this is actually, I'll show you a way this is really handy in a minute, other than how I'm using it here. This just lets me write less code, but I'll show you a way where this lets me parity match other functions, which is really cool. So I can say has of a kind, takes a number, returns a function that takes cards. Now I don't need cards. Mouse, get away from me. Now I don't need cards. And I can just call it like this. So that reduces the amount of code that I actually have to write. And I can just refactor those out, and that gives me the same exact functionality. So the way that works is when I call has of a kind 2, has of a kind receives the 2, and then returns back a function that takes cards and applies that 2 to that function, automatically returns back the value, true or false value. So another good example where you can use this, and go back to the cheat sheet, kind of like the card example a little bit better in this context. But now we can look back at that current example again. In this example, we have a function called convert units. And convert units takes many parameters. Actually takes 4 parameters. And I eventually want to call this, from a filter function, or map, map. And if I don't use currying, I have to apply all of those parameters when I call map. So it would be map, and then I'd have an arrow function, and then I would have to set all of those parameters in that arrow function. Using currying, I can say convert units, and then I can actually create different versions of convert units, like miles to kilometers, pounds to kilograms, and so on. Set those default values, and only accept the input, which is the number I want to convert. Once I have that set up, I can call it like this and say miles to kilometers, passing 10, or I can take this array of weight in pounds, and I can say, give me the weight in kilograms instead, by saying weight in pounds, map, pounds to kilograms. Notice I don't have to pass anything into pounds to kilograms. That delegate has one parameter which matches the parity of the function map, which requires a function of one parameter. So I don't even need to, it's implicitly taken care of for me, and I don't even have to write that. So I can just say it's very, it kind of rolls off the tongue. I know exactly what that piece of code is doing. I don't have to put comments around it and document it. You say weight in pounds, map to kilograms. How simple, like, we know what that's doing. We don't have to question. It's very easy to reason about. So we're currying with our cards here, so all of our tests are still passing. At least we didn't break anything by doing that. And this probably will be my last demo here. Notice our get hand rank has changed. Okay? Remember, we have all of these functions. Let's see. Let's start here. We have all these functions that basically has straight, has full house, has flush, has royal flush, has two pair, and so on. We have these true-false statements. They take an array of cards, they return true or false. They have all of that in common, so there's a pattern there that we can exploit. So instead of using that return early statement or that ternary operator, what we can actually do is create an array here. Okay? The first thing, or we're going to have objects in this array. The first property of that array is going to be an evaluation function. So we're going to use our functions as data now. We're going to put them in an array and use the power of an array to do our finding of the highest hand rank. For the default, I'm going to say HigherOrder. So I don't even need a function in here. I can say true. It's always going to return true because it's the lowest possibility. And it also has the weakest strength of any hand in poker. And then I can call the rest of my functions in here, HigherOrder, two pair, and so on, and give it a rank and weight those by strength. What's really nice about these being in an array now is I don't care what order they're in, because I can sort an array. So now my logic doesn't need to happen in this particular order, because I can call sort, and I can sort these by strength in descending order. So now I'm sorting on the strength property on the object that's in this array. And what I'm going to do once I've sorted this, I'm going to call find, another one of those array manipulation methods. And I'm going to tell it to find the first item that evaluates to true. So I've ordered them in highest to lowest order, so royal flush first. It's going to go through until it finds one that evaluates to true. Once that evaluates to true, it's going to stop. It's going to return that object, and then it's going to grab the rank off of it, which is that text, high card, pair, and so on. So what's nice about this is if you look over here at all of these, we can take, I'm going to hold down Alt and arrow, and I can move this around. Doesn't matter. I'm sorting it. So I'm sorting the execution order. So I can add functionality to the get hand rake ad hoc, and I don't have to worry about where I'm inserting that logic. I can actually pull, I could pull this array out. I could pull this entire array out, and I could allow that array to be specified in another library even. I could have all of these evaluations that are here. All these has something, something, something. I could take all the ones out that apply to, say, 5-card poker, and I could segment those from ones that work on any kind of poker, and I could mix and match and say, okay, I want to score a 5-card, I want to score a 7-card, and I could still rank them the same with the same algorithm. I could kind of do that ad hoc, and it doesn't matter what order they're in. So that's using functions as data. So the functions actually become part of this data set that we can act upon. And just like I said, I didn't declare any variables. They're all functions that do not mutate any type of state. And we were able to solve all of the poker scoring problem. I would imagine stuff like this is helpful if you're programming games or you have problems where you have a business problem where things are often executing in some sort of order, but you get a call from somebody and they're like, well, we have this new way of evaluating it. We need to add that to the stack, and either introduce bugs or have to go through a unit test, all that stuff to make sure you've inserted it in the right order. And there's a an object-oriented programming mechanism that does a similar thing. A chain of command pattern does something similar like that, where each item kicks off another task type of thing. So that's more of a functional approach to that type of problem. So some of the overview here. Are you guys already using some of these things in your applications? Maybe not to this degree, but like at least using map or some arrow functions or something. Does this presentation maybe kind of open up the idea of using some more of this stuff? Hope so. Otherwise, I waste a lot of time. I guess that was my second question. Will you use some of this stuff? And remember, you don't have to go like whole hog like I did. Like you can. If you have some very complex thing in your application, you want to kind of break it down to a couple functions. It can help you reason about that complex thing. You don't have to like attack your entire application from the ground up like this. You try to go completely stateless in JavaScript, you move on your mind. A lot of these things apply in React, doing React development. A lot of these same principles are shared in that framework. I think that kind of answers you free, like, this isn't meant to go whole hog. You could, if you want to. You may drive your coworkers crazy, so always find out where your team's level is at and go to that level. Don't go nuts and like give them this thing that's all functions and expect them to know what you're doing. So make sure you're on board with everybody at work. And then, it's kind of a personal preference thing, I believe, but, what are people's feelings on how easy the code was to read that I was writing? Did it make sense? Did the longer versions of it make sense to you? Like I said, it's kind of open to interpretation. Some people like to see that imperative process, but there's all these nice functions that are out of the box that do a lot of the things that we already write. So it kind of reduces the overhead in time. So there's some arguments to be had there.